Okay, so I'm Jeff Denworth. For those of you that have been to a DDN User Group before, you've seen me speak. I'm celebrating my 8th supercomputing with DDN. I'm probably like my 13th or 14th in total, my career. So fun to be back. Really exciting to announce not only a new product, but a new product architecture to this forum right now. So we're going to tell you a little bit more about that. We're going to tell you about all the other amazing things that DDN's been up to. Alex mentioned it. I just want to reference it again. Truthfully, everything that we do is really around driving down the cost of computing, whether that's from building really efficient storage platforms that support a lot of capacity. And you're going to hear, for example, Tommy talk about building a 20 petabyte system, which is certainly something that you want to make sure is cost effective. But from a performance perspective, we have to think about every single segment and aspect of the big data lifecycle and the workflow, such that we can make sure that there are no bottlenecks in your environment. We've been doing a ton of work, ranging from really working now with cluster schedulers to implement integrated systems with our APIs that we're releasing. We're working with embedded compute architectures. We've been doing that for a long time with the likes of our embedded platform, but we're taking that to the next level with the infinite memory engine. So we're going to talk more about that. And then we've actually been partnering with a lot of customers these days about really accelerating, let me just put on my timer so I keep myself honest here. Really accelerating applications and starting from the application and working back. And so Francesco's here, he's one of our business development people. We've actually done some work with a number of different research organizations. One example was at an oil and gas customer of ours. We partnered with one of our customers, iCheck, and managed to help this customer increase their application performance by 3 to 5x on just one of their applications. And beyond that, we've worked to help, I'll stay away from there, to increase application performance by up to an order of magnitude on other platforms. So we believe that providing real value to our customers is really starting with an understanding of the application and working back. And a lot of that thinking we poured it into the infinite memory engine product that we're going to talk about today. So we're pretty excited to kind of walk you through this. As Alex mentioned, these are the 3 pillars of our portfolio. I'm going to talk you through a little bit more about what we do special there. So some of you have seen this slide. This is our product portfolio. This is what we've announced throughout 2013. And certainly it's way too much to talk about in this forum. So I'm going to whittle down the discussion to only the things that are really new. And I want to double back to a discussion on DDN's engineering agenda, why that ties so tightly into our HPC agenda, and some of the things that we do special that really change the game from a perspective of you as an application user, you as a collaborator, you as a scientist. So we like to bucket this discussion, the one about our engineering agenda, into 4 different categories. Our penultimate focus is on price performance. The reason for this is we need to be competitive and we need to drive value for you, and we need to make sure that you can continue to scale your architectures by virtue of not having storage become an impediment to that agenda. Secondarily, we're very focused these days on research, collaboration, and data ubiquity. Aside from that, we do have a very robust scalability agenda. Alex alluded to that a little bit. We'll take you through exactly what that means in 2013 for DDN. And then finally, simplicity. We've got over 1,000 customers around the world. We're adding many more every year. And as we broaden out our footprint, more and more customers just want simple solutions that solve their application challenges. And that's a key focus for DDN. So let me just kind of talk to you about what's different about DDN in these categorizations. First, the one we like to talk about the most is always price performance. We're focused on driving down the cost of computing. Notice I didn't say storage. And so in order to do that, we need to be thinking about every single aspect of the storage deployment process, as well as the application management process. We bring a number of very unique capabilities to the table that no other organization in the world does. I'll start with the SFA platform, which is built from a state machine architecture. This is a heavily engineered product with 1 million lines of code that's designed to make sure that we get the absolute best performance extraction out of every single piece of hardware you get from us. From a caching perspective, if you think about the sprawl of cores that are happening in an environment and the proliferation of multi-core architectures, this all plays hell with your applications as it relates to them being able to do I/O to your file systems. So we've got a number of different technologies that really serve as an I/O deblender to make sure that you're getting the best possible disk utilization and minimizing your cost of storage performance through the process. The net result of that is we also have a lot of tools for just application acceleration, and being able to leverage next generation NVRAM platforms is absolutely part of this. I'm going to take a trip to the data center and just remind you all that we're providing the highest density storage platforms in the market, full stop. So we're requiring less floor space. We're getting better platform efficiency than anybody else in the market, which means that we're just collapsing the cost of data center, ranging from your space to your power to your cooling, and that provides value. And then finally, we're also focused on this convergence of compute and store. Why? Because it helps save money. We can collapse the amount of file systems or file servers that you need on a platform with the virtualization that we've worked on. And the Infinite Memory Engine is designed to complement an architecture that has state living natively in the compute nodes. So switching gears to collaboration. This has been a key focus of ours. Alex mentioned our WOS product. This is a geo-distributed system. I had a meeting with a customer yesterday, and he called it delocalized data storage, and I think that's probably one of the best descriptions of the platform. We're focused on enabling collaboration between a number of different sites, a number of different organizations, and really breaking down the access barriers to data. So WOS, first and foremost, is our geographic distribution platform. We've not introduced a whole new deployment modality for customers in that we're tying this natively into our parallel file system offerings. So WOS becomes a data synchronization system for your parallel file systems and allows a number of different organizations to talk in the normal file system semantics that they want to, but enjoy the added benefit of a global namespace where data is immediately available to any organization at the push of a button. Secondarily, if you think about a lot of the file system offerings that we have, we've been spending a lot of time on building out a platform that allows for data ubiquity. And what do I mean here? I mean, we have a multi-protocol access platform that allows for organizations to talk to a common namespace, whether you want to talk through objects, through files, or through objects, parallel file system clients, or through standard NAS clients, all with a common namespace that can be distributed all around the world. So both in terms of how you access a system and where you access a system, DDN is breaking down the boundaries of data collaboration. Talking a little bit about scalability. So scalability has been our thrust since day one. We've always prided ourselves on building the world's fastest storage infrastructures, particularly for HPC. We're also seeing that same thing happen in the web, by the way, where some of the most mission-critical applications that you're using when you fire up your laptop or when you turn on your smartphone are dependent upon DDN technology. Scalability is key throughout the entire agenda. So let's take it in two different buckets. Let's talk about your namespace. From a namespace perspective, we've been focused on scalability for a long time. We announced WOS in 2009. This is a 32 trillion object namespace that you can build either as your primary object store or as a tier of your parallel file system. And then we take it to the next level with the Infinite Memory Engine, where I'm going to talk to you about how we buffer cache parallel file systems and accelerate them by basically eliminating POSIX locking issues that have been troubling people that are deploying large namespaces for a long time. Taking it down to the storage level, scalability is also a byproduct of having very efficient and very consistently performant systems. So this part of the discussion, we focus more on Amdahl's law and eliminating the perils of Amdahl's law even when you're deploying tens of thousands of hard drives that can fail all the time. DDN has that problem solved. At the SFA level, we built systems that have guaranteed quality of service so that we can support a response time within any predefined period of time, so that as you're doing a strided write or a large file I/O, or a file read, I should say, that always happens as fast as you expect it to happen, even though the system may be going through some failure correction. And then in terms of non-determinism, this is something that we haven't really talked about before, but we have a number of different products right now that are not deterministic in how they store and how they deliver data back to an application. WOS is one where there's a client that knows anywhere in the world the best possible place to place data and pull data from so that you always get the best possible performance. And we've applied that same concept to the Infinite Memory Engine, where your cluster will always write to the most optimized place within the cluster or in the storage network so that you always get the best possible performance utilization. And that drives down TCO and increases your cluster efficiency. But I'd be remiss if I'd be remiss if I didn't hit 3 of my microphones at the same time. I'd be remiss if I didn't talk at all about simplicity. So if you've used our DirectMon product, you know that it's evolving very, very rapidly to be a very simple platform management tool that cuts across all of our products, by the way. File systems, object stores, and block storage systems, all managed by one simple, scalable platform. Simplicity also comes from reducing the amount of infrastructure in your environment. And the SFA platform allows you to eliminate file servers or even embed your computing applications within the platform. Infinite Memory Engine allows you to really harness the power of node local memory in a way that you haven't done before to reduce your overall networking, your storage, and your data center costs. From a storage perspective, self-healing storage is also critically important when you start thinking about how to manage platforms at scale. We literally have customers that have deployed 50 plus petabytes of our products, and running through the data center is the absolute last thing that they want to do. So we built a number of tools within our platform that enable organizations to not have to go through heroics to fix the system, because the system's capable of healing itself. WOS is the best example. You can lose a drive, you can lose a node, you can lose an entire data center, and the system will just correct itself from this arguably destructive failure and bring itself back to a full place of data protection performance. And then finally, one of the things that we have never talked about is we now support call home this quarter with our DirectMon product. So we'll know about when your systems fail before you do, and we'll be there to fix it in short order. So these are the things that we do to increase system simplicity. Beyond system simplicity, we have a robust ecosystem agenda that we're driving right now, really focused on taking the application back in mentality around how we optimize and deploy systems, so that customers, when they come to us and say, I have this application, we know exactly how to optimize that for whatever they're trying to do, their business agenda. But beyond that, it really helps us make sure that you as a customer are deploying the most cost-effective solution for these enterprise applications or for these research applications. So all of that kind of melded together, I believe, really results in the most comprehensive data storage and compute stack for at-scale computing. And at-scale is always relative to what your scalability level is today. We have systems as small as 4U, we have systems as large as a whole data center, and we're focused on, at every single level of scale in that scalability spectrum, building a complete end-to-end solution stack that takes the data management and data storage question mark off the table and makes it easy for you to deploy, manage, and scale up this infrastructure. So I'm going to take a few minutes and just talk to you about some of the new products that we're announcing at the show. So the 12KX is the evolution of the 12K family. We kind of have a little bit of our own TikTok going within DDN. This system will perform at 48 gigabytes a second of full bandwidth, so it's absolutely the fastest storage system in the marketplace. We happen to just beat the fastest storage system benchmark that we happen to set ourselves, so we're basically one-upping ourselves here, which is exciting. And it also features the same deep capacity scalability and all the features that you've known from the SFA 12K, and we're excited about that. The SFA 7700 is basically the little brother of the 12K. It supports all the same features that you get with the 12KX platform, ranging from the highest performance for its class in the marketplace to very, very simple ease of deployment and use with our DirectMon product, to hybrid flash caching to really control the cost of computing in your environment by making applications more efficient, making your cluster more efficient, and reducing the amount of hard drives that you have to deploy to hit a certain performance benchmark. The nice thing about our flash caching suite, which also applies to the 12K, is that, okay, we'll get to this in a second, is that it also supports a user-defined API. So we're going way beyond any other storage company in the marketplace by giving you the tools to define the priority of your data, to define the priority of your applications, and make sure that you're exploiting your investment in DDN technology by getting the best possible performance where you need it, when you need it. So we're really focused about caching in DDN. The reason for that is simple. Clusters are getting really, really threaded, which kills your storage system, and flash is becoming very, very cost effective, much more so than it has ever been in the past. So I'm reflecting on a slide that I told Sarp I stole from him, and I don't even know if he has it in his talk, but it'll be good because it'll be complementary if he does. We've spent a lot of time looking at our customers' application stacks, and surprisingly, the amount of I/O that they're dealing with is way smaller than they expect. And the caching tools that we're building into our platform allow you to basically take anything south of the 512K or 1 meg mark and place these into RAM, put them down into a flash storage tier when appropriate, stage them back up as the system automatically is capable of doing. And at the end of the day, avoid the perils of spinning disks for your smallest I/O without having you to regiment or change your application environment. So I like to call flash storage within DDN the HPC shock absorber. It takes all of the impact out of really, really nasty pathological I/Os away from the platform and makes application scaling simple for you. So I talked a little bit about SFX. I referenced the API. I'll come back to that in a second. We support today read caching that's totally automated, an instant cache warming capability that is also totally automated, and all of this is complementary to our dynamic RAM-based cache layer that we call React, where the system makes real-time decisions on what to send to RAM, or what to send to flash, or what to send to disk, so that it's always using the system resources the most cost-effectively as it can. But I want to take a specific second to talk about our API with SFX. SFX stands for Storage Fusion Accelerator. I named it. You can like it. You don't have to like it. I don't care. It's a little bit goofy, but it's really a brand around our flash caching suite that we've implemented really to harness the power of SSDs and bring systems that have the cost of spinning disk but the speed of flash in a way that is transparent to you as a user. I say that with the exception of really our out-of-band API that you can use to harness a much more powerful system experience if you choose to do so. We have in-band APIs. We automatically are, this is a technical term here, file system hint sniffers. We built, so basically we're listening to file systems GPFS and Lustre, and we're looking for opportunities to accelerate known processes in those file systems without having any intervention on your part. But we also provide an API, and that API allows you to do things like prefetch data into a flash tier and get almost instantaneously access from your data set when your application scheduler is ready to actually fire up that job. So some simple commands can allow you to dramatically increase your data staging performance and reduce the amount of time that your cluster remains idle. Had a couple discussions with really, really large customers that have something like a few hundred applications that they're running in their environment. And they said, this is great, but there's no way I could implement this at scale. And so we kind of reverse engineered the discussion and said, well, there's one thing that the API will be able to do that's really interesting, which is you can decide what not to cache. And at that point, you've provided an automated cache suite only for the organizations or only for the users that you know actually will take use of it and won't just abuse the rights. So there's a lot of flexible ways that you can implement our API, and I invite you to learn more about that at the booth. So just want to take a little bit of a second to talk about file systems. DDN has literally dozens of file system engineers around the world, part of our over 150 engineers that we have in our engineering team. And we're really focused on engineering value around trusted and proven parallel file systems. So we work, as you know, with Lustre and GPFS, and we're building all sorts of value-add tools around these platforms to make these systems easier to deploy, much more collaborative, much faster, as well as, I forgot one. Easy to access from any single protocol. So we have a multi-protocol engineering initiative going on where you can access files from an NFS client, from a CIFS client, or from a parallel file system client. That namespace is totally synchronized. And these are the types of features and capabilities that we're building into the platform so that it's easy to deploy a DDN system that adapts to the workloads that you're going to throw at it from a multi-user perspective, but you can also get to the data from a multitude of applications. Just want to touch on WOS. Alex mentioned 32 trillibyte, that's not even a word. 32 trillion objects that scale. Just to give you a point of comparison, GPFS, for example, does about 8 billion files that you can store in a POSIX namespace. So we're a little bit bigger than that. We built it for a number of different markets, one of those being collaborative computing. We also happen to build this platform for some of the largest social networking sites in the world, and we're deploying it at scale. Our largest customer right now has, as of today, probably something in the order of 80 billion objects in one namespace. The system's really fast. We sidestep POSIX, as I mentioned earlier. We can get about 10 terabytes a second if you've got the money to do so. 256 million objects per second. So this is the benefit of sidestepping a POSIX locking system altogether. And the nice thing is it's a distributed platform, supports declustered storage protection, and has best-in-class availability, either when you're deploying it in one data center or you're deploying it in 64. We can deploy advanced data protection mechanisms that really suit the data. And so everything is totally API-driven, where you decide how you want your data protected if you decide to do so. Otherwise, you can let the file systems that layer over top of this, such as, let's say, our GridScaler system, just manage a tiered namespace that can be distributed all around the world. So this is absolutely critical to research collaboration. And as I mentioned earlier, we've built a file namespace synchronization platform in WOS. It's much more than an object store. It's an intelligent system that really enables organizations to enjoy a common namespace that's distributed all around the world. So they never have to worry about getting their data. Even if the data doesn't live within your data center, you can pull it from any point in the network because it is a cloud storage system. It's designed from the ground up to be scalable and totally global. And that allows basically our customers to eliminate the silos of data that they have in their environment or in their research process and really change the way that they do discovery or storage. So we're going to hear from Circa today talking about a very exciting product that they're endeavoring on, and I won't spend any more time on that. So finally, I touched mostly on this. Call Home in DirectMon, really a lot of features in it since the last supercomputing. I invite you to come see it. We've got DirectMon on almost every single booth stop in our overall booth tour. Okay, so the stack's pretty great, but it's about to get much, much bigger through the virtue of our Exascale platform that really applies to people at every scale. We call this the Infinite Memory Engine. You might talk to some engineers in DDN that'll call it Project Iron Monkey. So if you've heard either of these names, that's what we're up to. And so why did we start this? Well, the market is kind of looking at advanced system architectures and saying, Moore's law has petered out from a clock rate perspective, and the only way that we're going to grow is by proliferating the number of cores in an environment, which ultimately creates both concurrency and also encourages things to break. We've done a lot of work with an R&D team that we've established in 2013, really to focus on advanced initiatives. These guys don't have a commercialization agenda. They're really looking at advanced technologies and exploiting technology trends so that we can in turn commercialize some interesting stuff for you all. And so they've been doing a lot of work on parallel file system scalability. And if you look at a POSIX locking system, particularly for shared operations, what you'll see is that we're about to hit just an abysmal state in terms of how systems scale. So the most perilous use cases are end-to-one applications or checkpointing, and we believe that they won't even be possible once you get to a certain point, which is actually much sooner than you all think it is. So we'll talk a little bit about what that is. So one of the ways to ameliorate this from a storage perspective, if you look at how hard drives continue to scale, and by the way, this is logarithmic, so it's a little bit deceiving. But the gap between disks and processors is widening, and obviously flash storage and hybrid storage architectures address that problem. And today it's already very cost effective. But more than that, there's a whole other suite of capabilities and technologies required to make this usable in an exascale and in every scale HPC context. So how am I doing on time? Oh, wow. Okay. So anyway, as I was saying, yeah, I've been talking pretty fast, haven't I? Okay, sorry about that. So IME represents really a revolutionary step function in terms of the DDN product portfolio in how we're enabling organizations to really scale up infrastructures as well as reduce the cost of infrastructure so that exascale computing can even be affordable. Think of this system as a distributed buffer cache system that sits between your file system and your application, and ultimately allows you to aggregate, protect, and serve up flash storage either within a cluster, on a network, in your storage system in a way that reduces the cost of computing, or at least the cost of data storage infrastructure, by 90%, 90% across the board. So we're looking at both the storage requirements, the I/O and the router node requirements, we're looking at networking, we're looking at data center, and all of this is materially reduced. But more than that, IME ushers in true scalability for parallel file systems. And so the platform is designed with advanced algorithms that we've been designing for some time that really allow organizations to do completely parallel, highly concurrent operations without hitting any of the file system scaling walls that are associated with traditional POSIX. And so this isn't just some sort of extrapolation that we've made. This is an actual output of some testing that we've done. And the interesting thing is this technology is not something that's being just kind of thought about in some sort of research lab. Thank you, Derek. We're already seeing bids for the technology happening at some of the largest supercomputing centers in the world, and you're seeing actually some of the not so large supercomputing centers start to scratch their head and think about how they can put more and more flash into their architecture. And I'm going to call it Iron Monkey. Infinite Memory Engine is really designed to harness this technology and present to an application space a file system semantic that scales well beyond traditional locking systems. So this is actual real numbers. We benchmarked against a bid that we're working on right now, just a 200 petaflop system, not so big, but it'll be about the size of your average system within about 3 or 4 years, and from a concurrency perspective. And so what we're seeing is that the system well exceeds what the design requirements are for that system, but more than that, scales totally linearly. And you can think about fragments per second in this model as metadata operations per second to a concurrent directory, or concurrently to a directory or to a file. So programmers no longer need to go through special hoops just to be able to get over the file system scaling bottlenecks that they've had before. What are the advantages of this product? Well, they're pretty simple. We built completely limitless scalability into the platform by virtue of some of the advanced algorithms that we've engineered, as well as have gotten patents on. We just got awarded one this week, in fact. It's fully POSIX and HPC compatible, so you don't have to rewrite your codes. You don't have to deploy new application middleware. No need for new libraries. It just works out of the box with your applications. We do support distributed data protection within the platform. So whether you're deploying buffer appliances that we sell, or whether you're populating your cluster with node local flash storage, we can aggregate that, we can harness it, we can exploit the performance of it, and we can also protect it in a way that we support any sort of pathological failure in the system. As I mentioned, non-determinism is a key part of this, and we believe that as you get into the exascale timeframes, even storage clusters will suffer from Amdahl's law in a material way, and so being able to dynamically avoid any of the kind of bad stuff that happens in a storage environment, particularly if that lives in your cluster, is going to be absolutely critical. So we've solved that problem with the Infinite Memory Engine. We've integrated with parallel file systems, so we're actually going to be showcasing, well, I'll tell you what we're showing in just a second, sorry. But one of the really interesting things about the platform is it's not just a big buffer for writes, it's also a buffer cache, we call it. So it accelerates reads as well. So we're looking at a number of different applications ranging from HPC checkpointing to doing very large output files to even doing things such as in situ analytics, all of this supported within a distributed global memory system that we've engineered. So it's really complementary to the work that we've been doing with caching so far. As I mentioned, we're building shock absorbers in our caching engineering effort, and this is just a really big shock absorber we've just engineered. And it's one that is we believe, requisite in terms of getting you to exascale. And so it's API controlled if you like, automatic if you don't. And in both cases, we're always taking best advantage of the resources and the components within your infrastructure by making sure that everything's dynamically cached and I/O is ordered as best as possible throughout the system. Okay, so Alex talked about the graph. What I would like to mention, or the table, what I would like to mention is that the benefits of this product only get better over time. As disks continue to flatline and next generation flash technology only gets faster, the benefits of the Infinite Memory Engine only get more and more acute. So we're pretty excited about that. Now, we are announcing a product, but we're also showcasing it. If you come to our booth, we have a little system running. It's not huge, It's 14 nodes, just using Dell nodes. We have high performance SSDs running in these nodes, about 7 each. So you've got something in the order of just over 2 terabytes, maybe a 25 terabyte or so second system built within the cluster. And so in this cluster, we've run 2 jobs on it. One is we compared the performance of a totally parallel operation versus a POSIX file system. And then the second thing that we've done is we've showcased the draining of data off of the buffer into a parallel file system. I don't have the numbers for the drain, but I can tell you that because it's a buffering system and because we can read as fast as we write, we have the ability to completely order I/O down to the disk layer, so that as you build these advanced architectures that consist of both flash and disk, we get the best possible performance utilization of your disk system so that you don't have to proliferate a lot of disks just to support the drain, and you always get best performance of moving data on and off of spinning technology. But in the flash part, things get really interesting. So I'm going to describe to you the testing that we're doing. First is we take these 14 nodes and we run a POSIX file system on it. In this case, we use GPFS. We've invited the Lustre guys here. We work with both. Just in this case, we decided to compare versus GPFS. And so we did 2 different types of I/O to the system. We fired up a concurrent job on 14 nodes where we did 8 megabyte writes off of the file system to one file, one directory. And that was pretty good. For GPFS, they got about 43 gigabytes a second. With the infinite memory engine, we're showcasing about 50 gigabytes a second. So not so spectacular. But the reason for that is that you don't see the pains of metadata locking at scale when you're only doing 8 megs across 14 nodes. So then we crank that down to 4 KIOs, which is about 2,000 times smaller of an I/O unit, which means that as we process these through the system, we can simulate a level of scale that's 2,000 times larger. And that's where you really see the locking pressure on a parallel file system showcase itself. And by the way, that gets you to just about the equivalent of a 12 million core cluster. That will be very commonplace in not too many years, actually about 1/4 the size of an average top 500 system by 2018. So we're not even talking about an Exascale system at all. And way earlier than the Exascale head wall that we're all running into, what you can see is that the infinite memory engine totally takes advantage of the flash resources. It scales completely linearly and takes the best possible performance advantage of the system such that it bypasses all of the pressure that you get from a locking engine. So we don't mean to pick fights, but the GPFS system performed at about 17 megabytes a second versus the infinite memory engine system that scales line rate about 49 gigabytes a second. So that's only about 200,000% faster. It's a little bit of a perilous benchmark, we know, and one where it's very pathological and nasty, but we believe that everybody's going to be facing this level of scale in not too long a period of time. So this is why we're really excited about the platform, and we hope you get a chance to come see it. That being said, I think I've taken up just about the right amount of time, miraculously. I have 2 minutes left, so who's seen Gravity? No, I'm joking. Okay, so just in summary, it's an amazing time to be a DDN, and I think equally it's an amazing time to be a DDN customer if you understand all that we're doing. From a price performance basis, from a collaboration basis, from a data ubiquity basis, even from just the notion of deploying more and more simple systems that are quite sophisticated in the technology that we've engineered. We're really focused on kind of wrapping this up and providing the best possible experience for you as a customer. So thank you to our users for coming to the user group, and thank you for being our users and being our customers and continuing to provide feedback. We've got hundreds of meetings at Supercomputing, and we're looking forward to talking to you all. And in the meantime, we're going to hear from some pretty amazing customers. So thanks, everybody, and we'll see you on the floor.